Welcome to this Vib Tip session. Today we are going to talk about the heart of a vibration test system, the armature. The armature is a magnesium or aluminum structure suspended inside the shaker body. Wound around its lower part is a coil called Voib's coil, tightly bound to the armature by an epoxy resin. The design of an armature is a complex thing, since we look for a lightweight and strong structures, concepts that are difficult to match. One of the key features of an armature is its resonance frequency that highly determines the frequency range where it can be used. First, let's take a look to the basic classical shaker mechanical model. We have three groups of masses connected by spring damper systems. The first mass includes for sure the shaker body, but depending on the type of isolation system to the surrounding ground, it can also include trunnion, a reaction slab, or even a seismic mass. The second mass is the armature part plus the device under test. It is connected to the shaker body by the suspension system that allows axial movement relative to the body while restraining all other motions. Today, we concentrate in the last mass, the Voib's coil, and its elastic interaction through the epoxy resin with the armature, so the third mass spring damper system. When we start the sine duel, initially the three masses move as a single unit until the isolation resonance is reached, and progressively the system minimizes vibration transmission to the ground. Then, depending on the configuration but still at low frequencies, we find the suspension resonance until the shaker body movement reduces and it becomes negligible. At high frequencies, we find the armature resonance, where two significant phenomena happen. First, as in any resonance, the response of the mass, in this case armature plus DUT, increases substantially compared with the excitation. This means that for keeping the same acceleration level, we would need less drive signal. So somehow we can say that the armature is helping us in our test. This is true until the anti-resonance of the armature starts, where we would need a higher drive signal to move the armature, leading to a serious risk for the equipment. This frequency must be absolutely avoided. Anyway, it's important to notice that the armature is working around its resonance frequency and significantly fatiguing with the risk of a premature failure or, as a minimum, the need of accelerating a preventive maintenance interval to check for potential problems. It is not recommendable to regularly work around the armature resonance frequency. On the other hand, in the armature resonance frequency, there's a 90-degree shift between the movement of the armature and the Voib's coil. Therefore, both masses do not move synchronized, and the epoxy that bonds the coil to the armature suffers. This is even more significant after the resonance peak, where the phase shift is 180 degrees, and armature and coil try to move out of phase, with a high risk of breaking the epoxy and detaching the coil from the armature. Summarizing, as most of you know, manufacturers limit the shaker's highest frequency of use to a figure usually below the first armature resonance frequency, or sometimes just slightly higher. We have seen the reasons behind this limit and the consequences that can result from working around the armature resonance frequency. Thanks for attending, and let's meet in the next Vib Tip session.